This is Algebra Lesson 7.2, Solving Systems of Equations Using Substitution. First example says, use substitution to solve the system. So what we will do is take each half, the right half of each equation, and we set them equal to each other. So that'll be 2x minus 8 from the first equation, and negative 6 plus 16 from the second equation. Making them equal, then we would use our standard solution method, adding and subtracting using our inverses on both sides until we get x alone. So I like to start by combining my x terms. I see a positive 2x on the left side and a negative 6x on the right side. My advice is to get rid of the smaller first. So since negative 6 is smaller than positive 2, I will get rid of a negative 6 by adding 6. I will add 6x to both sides of the equation. My 6's will cancel on this side, and I will have 8x minus 8, and I will have 16 on the other side. Now this looks like a standard linear equation, so I'm going to continue by bringing my constant terms together. I want to bring my 8 away from the x, so I will add 8 to both sides. That lets me cross off the 8's, and on the left side now I still have an 8x, but my minus 8 is gone, and on my right side now 16 and 8 gives me 24. My last step is to divide both sides of the equation. I want to get x alone, so I want to be able to cross off the number in front of x. So I will divide by 8. That lets me bring the x down, and 24 divided by 8 is 3. Now I should have left a little more space because we're actually not done yet. When you solve a system of equations, you always get two answers. We get an x answer and we get a y answer. So this is my x answer. To get my y answer, I'm going to take that value for x and I'm going to substitute it in to my original equation for the x. Now I actually want to do that for both equations. You can do it for one or the other, but I like doing it for both because then it's a good way to check your answer. I want to see if I can do this. No, that's not going to work. Okay, I can fit some space over here. We will substitute that 3 in for the x. 2 times 3 is 6. 6 minus 8 is negative 2. I will also substitute that 3 in for the second equation. Negative 6 times 3 is negative 18. Negative 18 plus 16 is negative 2. Since my two answers matched, I know I have the right answer. Y equals negative 2 and x equals 3. My next example says, on a rural highway, a police officer sees a motorist run a red light at 50 miles per hour and begins pursuit. The motorist is 0.2 miles down the road when the officer leaves the intersection at 60 miles per hour. When and where will the officer catch up with the motorist? So I need to write my two equations to represent the situation. If I'm looking at the motorist, he was 0.2. He was 0.2 miles down the road, so that is his starting point. And he was traveling at 50 miles per hour, so that is his speed or his rate of change or his slope. The officer was at the intersection, so his starting point is technically 0. And he was traveling 60 miles per hour. So normally when we write an equation, if the intercept is 0, we would just leave that off. So really we just have y equals 60 plus x. So to solve using substitution, I will set my two equation halves equal. Start by subtracting or eliminating the smaller of the x's. So I will subtract 50x from each side, since 50 is smaller than 60. That leaves me with 0.2 and 10x. I don't have the same step from above. I don't have a constant to bring together since that 0 got erased. But what I can do then is go on to the next step, which is divide both sides. I'm dividing by whatever's in front of the x. That lets me eliminate. And 0.2 divided by 10 is 0.02. Which seems like a really small number, but remember we're talking about hours, miles per hour. So 0.02 hours is actually 1.2 minutes. If I multiply that by 60. Okay, so again, we're not done. We have an x, but we still need a y. I'm going to substitute my x value back into my equation. I got 1.2. And on the second one, okay, so real world meaning of the solution. I kind of did that already because I got x is 0.02. That means 0.02 hours or 1.2 minutes. That's my real world solution. It'll take 0.02 hours for the police officer to reach the motorist, and they will have traveled 1.2 miles down the road before he catches him. Okay, that is it for the notes. Good luck on the exercises.